As the introduction to this unit of study, I think I showed you this flashlight that doesn't require a traditional battery to operate. In a way, you're the battery. You provide the energy by way of the chemical potential energy you get from the calories that you consume in your food. See, if I do the work, I can shake back and forth, and what's moving through here is a magnet that moves through a coil of wire. The forces involved there are conservative. In other words, it's not generating wasted thermal energy. All that electrical energy that was just produced as I did work to convert chemical potential energy into electricity is stored in a little battery, rechargeable battery in here that allows me to operate the flashlight. If it ever runs out, all I have to do is shake it some more. Now, I can show you that this is a magnet. It picks up those paper clips fairly well, doesn't it? So another version of this here, the same thing. There's my magnet. In fact, oh, that's strong. There's the magnet. This is just a metal rod. But when the magnet sticks to this metal rod, as long as it has enough iron content in it, then the whole thing becomes magnetized. Okay, so yeah, indeed, when I move a magnet through a coil of wire, by way of something known as Faraday's law of electromagnetic induction, I can convert calories, chemical potential energy, mechanical energy, harnessable energy into another form that can be stored. So the electrical energy that I'm producing, and you can see my ammeter is registering an electric current. Instead of feeding this into a meter, I can connect this into an electrical storage device. This thing is called a capacitor. However, I'm not going to get a lot out of it. I'm generating probably less than milliamps of current, probably microamps of current. So what I need is a better version of this. So here I have a handheld generator, and in essence, it involves the same components. There's a coil of wire and a magnet, but by cranking it, I'm able to produce a larger amount of current out of this device. So I'll show you that the energy I'm producing is mechanical, that it can be harnessed and recaptured. I'm doing work. I'm transforming chemical potential energy into electrical energy, and it's being stored in this capacitor. If I disconnect it, nothing happens. But notice, when I reconnect it, all the energy comes back again. If I connect it in the opposite manner, does it spin the other way? That's interesting. In any case, that energy is here, available, and I can use it at will. This has something to do with the regenerative braking in electric and hybrid vehicles. As you drive your car, instead of using the chemical potential energy from the food we eat, we use the chemical potential energy in gasoline, right? Instead of using gasoline, what if we used an electric battery? What if we used a storage device like this? Then we could connect it, and we can use that to make an axle spin. And so all that's missing here are the wheels, right? So we have something spinning, and we could use that to drive our car down the road. Now here's the thing. As long as your car is already driving, in cases where you're either going downhill or coasting, then the axle is already spinning. And as we've seen, I can take a spinning axle and use that to produce an electrical energy output. So this is what happens in the braking process of electric and hybrid vehicles. Instead of using the friction between the brake pads and the rotors to waste the car's kinetic energy, mechanical energy, into thermal energy, we take that kinetic energy and use it to produce electrical energy, which is fed back into the car's battery to store it when the light turns from red back to green. So I'm not sure why all of our vehicles aren't electrical, or at the very least hybrid. Whenever I drive, I'm constantly thinking about this. Although I am a physics teacher, I don't spend my entire day thinking about physics, except when I'm driving, it comes up a lot. When I'm at the top of a hill, I often pop my gear shift into neutral so that I can drive based on gravitational potential energy instead of chemical potential energy. And when I'm approaching a red light, if I see it well in advance, again, I take my foot off the gas pedal, and instead of hitting the brakes, I pop it into neutral, and I at least let the air resistance and rolling friction bring me to rest instead of engaging the friction pads and the rotor. So I'm kind of interested in this thing called hypermiling, of trying to get the most fuel economy I can out of my traditional combustion engine. So maybe as you go around driving your car, having learned about the law of conservation of energy, you're more aware, more cognizant of the ways in which energy is being converted and how we can conserve energy in its mechanical form.